Hello, everyone. My name is Sachin. I'm a PhD candidate at the University of Utah, and today I'll be presenting our work on IPv6 in the web ecosystem. This project was carried out under the mentorship of Professor Benson at CMU, and I'm excited to share some of our measurements and findings with you. The goal of this project is to characterize how IPv6 is used in the web ecosystem in terms of adoption, performance, security, and resilience. This talk primarily focuses on the adoption part. For studying this, we need to make a country and website set. So we wanted to cover diverse regions and we want to pick regions which have good vantage point coverage, for example, for bright data or through VPNs. And we also wanted a diverse set of websites, like top global websites, regional websites, and government websites. So for top global websites, we rely on Tranco. For regional sites, we rely on Cloudflare Radar. And for government lists, we rely on IMC23 study of choices and control by Rashna and others. So performing the country selection, we select 28 countries, group into 13 regions. We pick the regions by Asia, Europe, North America, South America, Africa, and Oceania. And then this is the plot that shows what was the coverage of this study. So these are 28 countries, and you can see we have a good coverage in South America. We have 3 country coverage in Africa. We are covering Australia and New Zealand. So all these countries are picked based on 2 particular points. First, they should have a vantage point of VPN in this case, and they should have the website list. So for constructing a website set, first of all, we go per country. We use 100 government websites from IMC23 paper. We take 100 popular regional websites through Cloudflare, Radar. So we have 200 sites, and for 28 countries, we have 5,600 websites. And then we have the other set of global popularity Tranco, which is 4,500 in total. How we pick it is we take top 1,000 from Tranco, which we call Tranco top 1,000. Then we randomly pick 1,000 websites from 1,001 to 10,000, which we call Tranco mid in this case. And for the remaining, we pick 2,500 randomly, and which we call Tranco last. After picking all these websites, our final data set is around 10,000 websites, which is 5,600 country-specific websites and 500 Tranco websites. Now, we start our trolling and collecting the resources from a single vantage point, and we have 28 vantage points. We visited each site, which is the 10K website set that we talked about in the last slide. And we use browser-based crawlers to load the landing page and record all the network requests. And from this, we extracted all the URLs. So from this step, we got 100K unique URLs, and we extracted the domain information from those. So we got 25K unique domains. This step not only captures the main site, but it also captures the dependencies of each main site. Then we use a multi-vantage DNS measurement technique. For each of these 25K domains, we connect via VPN endpoint in each of the 28 countries. And then we ran DNS lookup for both IPv4 and IPv6 record. To maximize the RP harvesting associated with the 25K domains, we use multiple DNS resolvers. So we use 8 public DNS resolvers from each vantage point. And these resolvers include Cloudflare, Google, Quad9, OpenDNS, even Yandex and LUDNS. So this plot shows how the number of IPs or the percentage of IPs we recorded increased with the number of resolvers we used in our approach. So the blue line shows IPv4 and the orange line shows IPv6. And the x-axis shows the number of resolvers used, and the y is just a CDF. So as you can see that 66% of the IPv4 addresses, we got it from only one resolver, and we got 30% of the IPv6 addresses with one resolver. By resolver 3, we see significant amount of jump, 93% of IPv4 addresses and 74% of IPv6 addresses. And by resolver 4, these numbers reach around 95%. And definitely after resolver 5, we can argue that we got diminishing returns. And this other plot shows the same data, but in absolute terms. So this also shows that we harvested way more IPv6 addresses as compared to IPv4. And this also shows that multiple resolvers, especially for IPv6, can help to find multiple IPs associated with a particular domain. Based on the IPv6 addresses we harvested, we map the initial website set of 10K websites to check how many of those actually support IPv6. So for top Tranco, we found 66% of these sites have IPv6 support. For mid Tranco, we found 65%. And for the tail or the last Tranco, we found 64% of these sites have IPv6 support. So overall, based on these numbers, we can say that IPv6 support is consistently high and fairly uniform across Tranco popularity tiers. We did the same for regional websites. We found that IPv6 support is already high in regional websites, around 45 to 75%. So this plot on the x-axis shows the countries that we studied. On the y-axis shows percentage of websites supporting IPv6. And this plot is just sorted from lower to higher. So there are some variations, like Nigeria and India are closer to 50% mark, while Sweden, Romania, and Japan are roughly around 70%. Most other countries cluster in the lower to middle 60% range, showing that IPv6 has become a mainstream adoption for regional websites as well. We did the same for government websites. And in terms of government websites, we found strong country to country variation. This plot again shows the countries on the x axis and the percentage of websites supporting IPv6 on the y axis, and it's sorted from lower to higher. So in this particular case, United States and Taiwan has the lowest adoption rate, which is around 35 to 40%. And on the other side, Kazakhstan and UAE shows 100% adoption rate. At the same time, many countries have a very high adoption rate, as a large block of these government websites sit in the 80 to 95% range. Compared to regional sites, government sites shows much country to country variation. Some governments are clearly IPv6 leader, while few are still catching up. So the previous plot showed us what percentage of the website set support IPv6, but now we'll talk about the dependencies. So this plot on the x-axis shows the percentage of embedded dependencies that support IPv6, and y-axis shows the percentage of websites. So you can see many clusters around 0 and 100. So in this particular case, for example, the bin at 100 shows that for Tranco, around 23% of the Tranco sites have all their dependencies reachable over IPv6. The rest are spread across the middle, meaning partial IPv6 support. The main site may be on IPv6, but some of its resources are still on IPv4 only. We did the same for the government websites. Compared to Tranco sites, government site shows much more variability. For Tranco, we mainly saw a big mass at 0 and 100, with fewer sites in the middle. Here, the government sites are spread across the whole range from 0 to 100, with many bins between 40 to 90% of population. This suggests that while some governments have IPv6 for their dependencies, others are still in various intermediate stages of migration. We also investigate how many network hosts each IPv6 domain and how many organizations it is associated with. So for that, we use IPinfo ASN dataset to infer the ASN org information. Our dataset has 12K dual stack domains. So these are the domains out of the 25K domains that we harvested. 12K are available over dual stack. So number of distinct ASN per domain. 64% of the domains were served from one ASN, 23% from two, and 13% more than three ASNs. This shows that most domains are still served from single network, but a non-trivial fraction is spread across multiple ASNs. We also find instances where the same domain is hosted across different providers over IPv4 and IPv6. And to find out that, we compare the organization name derived from IPv4 and IPv6 addresses. We found that 22% have different provider set for IPv4 and IPv6. And we also find some structural differences. For the domains which have the same provider set, 82% of them are just hosted on one ASN. And for domains which have a different provider set, 100% of them are hosted on more than two ASNs. And about 53% have exactly two ASNs, and 47% have 3+ ASNs. For one of the example is a Turkish government websites. On IPv4, it is hosted on 4 different providers, and on IPv6, it's only hosted on one provider. There's another example from a Tranco website, which is hosted on 2 different ASNs over IPv4, but on 5 different ASNs on IPv6. This was overall the summary of our work, and I'll take a brief minute to talk about what we are working on right now. We are looking at certificates over IPv6. We are analyzing the TLS certificate associated with the domain when reached over IPv6. We are also analyzing the TLS configuration, versions, ciphers, and other security setting over IPv6 to IPv4, and also across different IPv6 addresses for the same domain. We are also studying the IPv6 geolocation, which is, we found that some IP addresses were not correctly geolocated in the geolocation database. We are trying to quantify how many of those are not correctly geolocated and try to see that in which region those are actually located. In summary, IPv6 is widely deployed but not universal. Many Tranco, regional, and government sites support IPv6, but some countries and certain categories still lag. Looking at the resources, not just the landing page, reveals some gaps. A site can be on IPv6 while the key embedded dependencies remain IPv4 only. IPv6 content is also hosted on different ASNs and organizations as compared to IPv4, reflecting usage of multi-provider infrastructures. And in this particular case, measurement choice using multiple vantage points and multiple DNS resolvers help us to see the full or the bigger picture of IPv6. Thank you for listening. And as this is a recorded talk, please feel free to reach out if you have any questions, feedback, or ideas. Please get in touch. Thank you.
Thank you, Sachin. Theo is available to take questions.
That's very interesting work, really interesting. The only comment I have is that Akamai often hosts its own servers in different other providers, and Telecom Sparkle is one of them. Sometimes they use Akamai's IP address space, sometimes they use the other providers. So in Telecom Sparkle, I just checked now, the servers are numbered with the Sparkle's IP ranges. So maybe it appears that it's different providers, but it's actually just Akamai with IPs from different providers.
Yeah, I think we'll take that into account for a lot of what we've done. It's not a huge issue right now because what we look at is the first party and landing page and objects not on the landing page. And then we try to figure out if it's IPv6 versus IPv4. So I think on that perspective, it doesn't matter whether it's Akamai or not Akamai. I think some of the follow-up work, that does become very crucial.
Thanks. Nice.
So just following up on that, we have a data set of what we call IPv6 offnets. So if you're interested,
yeah, we're definitely interested.
Yeah, so we can provide that to you.
Hi, Tel. Nice work. Which VPN did you use, and did you validate the endpoints to make sure that they were where you think they were?
Yeah, Sachin and his advisor actually have another paper that does a lot of that validation. We started out with Bright Data, and I can't remember the second one, but we ended up switching to what they had used for the other IMC paper. So it's all Sachin that did all the work. I should start with that.
Just one quick comment. I noticed the small numbers about IPv6 in government in Brazil. When you run the measurements, when the measurements were run?
So these measurements were run, I think, a month ago.
Okay, because about 1 month ago, the Brazilian government deployed IPv6 for their government's website. So maybe you want to try to run it again to check if it changed. Thank you.
That sounds like a blog post for me. Any other questions? So I saw in the list of countries that have deployed IPv6 for government, you have seen, I see South Africa, Kazakhstan. So it seems like these are anomalies because you wouldn't expect those countries to deploy IPv6, but was it really the case?
I guess when we say a country has deployed IPv6, we know the government website. We've tried to figure out where the government website is hosted. Their hosting provider is using IPv6. It's not the case that the government itself is using IPv6. So Vasilis had this comment about looking at Akamai. If stuff is hosted on Cloudflare, I imagine Cloudflare will be using IPv6. So I guess there's some imprecision there that we'll have to go and fix.
Okay, thank you.
So
The set of countries that you selected was
from the 61 countries that is of choice and control, Russian speaker.
So just to respond to Amrish's comment, actually it's countries which are late to the internet game that are starting to catch up with IPv6 a little more rapidly. It's a mixed bag, but I find that whenever I come to Europe, I'm always disappointed when I'm in a hotel and I find myself on the experimental internet from the 1970s. But when I'm in Bhutan, it's native IPv6 everywhere I go. So I'm not surprised that places like Kazakhstan have IPv6 government services, because locally IPv6 probably works better. I'm from Hong Kong. The Hong Kong government is also IPv6 native, but the local ISPs are a problem. But no, so anyway, it's really interesting research, and it's interesting to see IPv6 in different governments being used.
Thank you. That concludes our first session. You do have questions?
I just wanted to ask what IP to country database was being used, because that's very critical. I know who's the ones that are shilling to the researchers very much? IPinfo, they got good stuff. You go to them, they do under the table deal. They hand you some fresh database. I don't know. I got a contact as well. Are you using that stuff?
Yes,
Yeah,
we also
okay.
emailed them, and
Okay.
under the table, they gave us the USB stick.
They gave you the good USB shit. Okay, nice. Okay, just checking.
So we are actually going to follow up with them with some of the issues we've had.
Yeah, they got some issues. They got some big issues.
Whoa, they're amazing. They're amazing.
They're amazing.
All right.